My dear students, other viewers and listeners, I, Professor Manohar Lal, Director, School of Computer and Information Sciences, welcome you to this part 5 of the programming language LISP, which is a programming language of artificial intelligence. In this lecture, in continuation of our earlier lectures, we'll discuss some of the features of the language LISP and its application in solving problems. Friends, in the previous lectures, we discussed a number of characteristic features of the language LISP. Also, we discussed a number of inbuilt functions. However, any programming language, the power of it lies in defining new functions which are not built in, but rather are constructed through the provisions in the language based upon the inbuilt functions. So today, in the beginning, we'll discuss how to define user-based functions. So friends, let us discuss the definition of a function. Functions construct in the programming language LISP is given as is on the slide. First of all, a left parenthesis is there, then the word define is there, D-E-F-U-N. That is, whenever you intend to define a function, first there should be a left parenthesis followed by the word define. Then whatever name you intend to give to the function, then the parameter list, and finally whatever are the sequence of instructions or commands which are to be given to the computer system, and finally a right parenthesis. In my earlier lectures also, I have said that the pair of parentheses plays a very important role in the language LISP. Any pair of parentheses, if misplaced, may have totally different meaning. Therefore, we have to be very careful while placing pair of parentheses. So, in the case of definition of a function, we must bind whatever we are going to write on the right and left by the appropriate parenthesis. Then after the left parenthesis, the first word has to be define, and the rest of the things will be more explained when we look at an example how a function in the language LISP is defined. For this purpose, let us have a look at the next slide. Suppose we want to define a function fxy of two parameters x and y, so that fxy is equal to x cube plus y cube. It is mathematical definition of the function fxy, that is, it returns the sum of the cubes of two variables or two parameters which are supplied to it. Now, its definition in LISP is something which follows the arrow given on the left. As I mentioned earlier, there have to be a pair of bounding parentheses followed by the word define. Now, after define, we'll write the name, which is generally suggestive of its function, because we want to find out the sum of the cubes of the parametric values. Therefore, we suggest or give the name sum cube, S-U-M-C-U-B-E. And as I mentioned earlier, once name is given, then the list of parameters within pair of parentheses is given. In this particular case, because we are going to use two parameters, namely x and y, so these two parameters are formed in the form of a list by bounding x and y by a pair of parentheses. And once the parametric list is given, then what is the body, what sort of commands are to be followed by the list system is given. And as I mentioned earlier also, that LISP is a prefix notation. Now, for x cube plus y cube, we have to find out the sum. So the sum operator is written, the cross is written first, and then we have to find out the cubes of x and y's, and we know the cube of x can be obtained by multiplying x by itself 3 times, and similarly y cube is obtained by multiplying y with itself 3 times. So friends, we can see that the last expression following the list of x and y, we are having an expression plus followed by star x, which returns x cube, followed by star y, which returns y cube. So ultimately we will be getting x cube plus y cube. One thing which need to be noted is that whenever we give the definition, then in that case the name of the function which is being defined is returned as a value of the definition. There is a difference. Value of the definition and value which is returned by application of the definition of a function, these are two different things. That is, once you define a function, when you are not giving the parametric values, just you are giving the definition or the syntax of the code of the definition, in that case the name is returned. So in this particular case, sum cube, SUMCUBE, as single word or single symbol is returned by the Lisp system. What is the significance of this? Now if you apply list to this, then it will be a list of a single symbol, namely list of sum cube. And if we find out the length of that list, naturally, because the list consists of only one symbol, therefore the length of the list is 1, and hence you can see the last line, that is whatever is the definition, define sum cube, x, y, etc., etc. If we make it in a list, then that list is list sum cube, and finally if you find out the length of that, then the length will be 1. I hope this is very clear. I have taken this last part only to emphasize the return value in this particular case will be the symbol sum cube. Symbol sum cube in this particular case is formed into the form of a list, and list ultimately is length of it is found. So friends, now we apply it, and in Lisp, application of a function by supplying the argument is called function call. It is generally in other languages also it is called function call. So suppose after that definition we associate value 3 with x through the setQ command, and then we call the SumQ function with 2 arguments, namely 2 and x. So we can see that once the arguments are given, those are evaluated. 2 is evaluated to 2 and x is evaluated to 3 because setQ x3 is there. So the value of x on evaluation becomes 3. So actually the function SumCube is applied to 2 arguments, namely 2 and 3. And we know that the definition actually finds out the cube of the first argument and then finds out the cube of the second argument, which is 3 in this particular case, and finds their sum. So 2 cube is 8 and 3 cube is 27, and their sum is found. So ultimately the value 35 is returned. So friends, in this way a function in the language Lisp is defined. You may not look at the slide, please. Please need not look at the slide. So friends, we have already discussed a general definition of a function. But we know it is not, the execution of a function is not generally required to be only execution of one statement followed by execution another statement and so on and so forth. Rather there are conditions. We know, for example, when we are computing income tax of employees, then there are conditions. If the income of a particular employee is less than 1 lakh, say, then there may not be any tax at all. If the income is say between 1 lakh to 5 lakh, for example, the tax rate may be say 15%. Again, if the income is more than say 5 lakh and less than 10 lakh, the income tax rate will be different. And so as the income range increases, the rate of income tax may also increase. What I want to emphasize through example is that the execution, in this particular case, the rate of income tax may be 10%, maybe 20%, maybe 30%, depending upon the income range. So what I mean to say, we need to find out a mechanism by which conditions can be applied. So a condition is checked first, and depending upon the truth of the condition, only that part for which the condition is true is applied for execution. So the conditional statement syntax is very important for each programming language. So how this conditional clause is provided in the language Lisp, let us have a look at the slide. The slide says that first of all, in order to indicate to the Lisp environment that now this is a conditional statement, we write a parenthesis, left parenthesis followed by the word cond, C-O-N-D. And then a number of clauses are there in which the first S expression is a test. And once that test is done, and if it is true, then the rest of the expressions, S expressions, are evaluated. For example, there are test 1, test 2, test 3, test n. And suppose that test 1 is false, then rest of the expressions in that particular clause are not evaluated or executed. Suppose test 2 is true, then all the expressions which are following test 2 are executed. So whenever a test clause comes out to be true, the statements following it are executed, and those for which the test clause is false, the statements following that test are not executed. So friends, for this, in order to clarify it further, let us have a look at the example. For example, we want to find out the maximum of 3 given numbers. The given numbers may be called x, y, z. We call our function our max3. As I told you, whenever a function is to be defined in Lisp, first of all, a pair of bounding parentheses left and right are used. Then the word define is there. Then the name of the function which we intend to define. So in this particular case, the name of the function is our max3. And the name of the function is followed by the argument list. In this particular case, there are 3 arguments which are enclosed in a pair of parentheses to make them a list. So the list of parameters is there, which is list of x, y, z. But we know that one of the ways of finding out the maximum of 3 numbers x, y, z is that first we compare x greater than y. And if x is greater than y, then we compare x with z. And if this is also true, then the value maximum of x, y, z is x. However, if suppose the last condition x is not greater than z, that is, it is false, then the value x is not returned, as I mentioned earlier, that whenever a condition is false, then in that particular case the statement following that condition's test is not executed. So if we assume that x is greater than y is not true, then the value x is not returned. Rather, we go to the next statement. This T is used for the purpose that this statement is always true, that is, you must execute. So what is happening, that if x is greater than y, but x is not greater than z, then friends, we know that z is the maximum of the 3 numbers x, y, z, because x is greater than y we are assuming. Also we are assuming that x is not greater than z, therefore z is the maximum, and therefore z is the value which is returned. Here I want to again emphasize that the word T means that the condition is true. That is, whatever is the action stated by the statements following it must be executed, and the statement following T is that return the value of z. That is, z will be the value which is maximum of the three given values x, y, z, because of the fact that x is assumed to be greater than y, but x is not assumed to be greater than z. So under these conditions, however it may happen that x may not be greater than y at all, then in that case the three statements cond greater than x, z, x, t, z will not be executed. As I mentioned earlier, that the statements given on the lines cond followed by this, followed by t, z, etc. are executed only under the condition that x is greater than z. However, if x is not greater than z, then none of these statements will be executed and will be going to the next statement which is given on the next slide. Then what we'll do? If x is not greater than y, we will try. This means y is greater than or equal to x. If x is not greater than y, then y is greater than z. Y is greater than x. So in that case, the possibility of y or z, these are the only cases which are left. So first of all, we try for checking whether y is the maximum of the three, because already y has become greater than x. So what we'll do? We'll test y with z for comparison of being greater. And if y is greater than z, then we have already seen that y is greater than x, and therefore y will be returned. That is, y will be the maximum value. However, if y is not greater than z, then the clause y will not be executed. That is, in that particular case, invariably z will become the maximum value. So friends, I hope that now it is clear that how the cond statements work, how a definition of a function is given, etc. Now let us see another example, another special case. Friends, as I just now mentioned, that cond is very important in the sense that the sequence of statements, their execution depends upon the conditions. As I mentioned earlier, if the income of a particular person is less than 1 lakh, then what will be the statement executed? Something like this: the tax payable by the person is nil. Similarly, when the income of a particular person is, say, in the range of 1 lakh to 5 lakh, and the tax pose is at the rate of 10%, then whatever is the income of the person between 1 lakh to 10 lakh, whatever may be the deductions, etc., then whatever is the taxable income, 10% of that is charged. So what I mean to say, the computation of finding out the 10% of the taxable income is only executed when the condition that the income is between 5 lakh to 1 lakh. So conditional statements are very important in any programming language, because most of the solutions of the problems require testing of condition. Now we come to another very important construct in language Lisp. We know a number of steps are generally executed. For example, again let us take the case of computing income tax. Now suppose there are 1 lakh employees. Now after computing of the income tax of the first person, we will compute the income of the next employee, and after computing the income tax of the next second employee, we will compute the income tax of the third employee, and so on and so forth. However, for computing the income tax of each of these employees, we will not have a separate code. Otherwise the code length will become very large. So what is the provision? Actually, the sequence of statements which are used for computing income tax are same, whether it is employee number 1 or employee number 2 or employee number 10,000 or whatever it is. So what I mean to say, there must be a mechanism in the programming language which allows us to execute the first statement after having executed the last statement for the previous data. Then again the same sequence of statements or same code should be useful in finding out the income tax of the next employee. So, but how the system knows that now after having executed the last statement for a given data, we have to go to the first statement for the next data? Every language has its own mechanisms which And this type of mechanism by which we can jump from the last statement to the first statement is called iterative loop or something like that. But the syntax of these iterative loops in different languages are different. So what is syntax in the language Lisp? We will have a look now, and then we'll use that syntax in defining some functions which use iterative aspects of a programming language. So let us have a look at first of all the definition. The definition is something like this. Please look at the slides. Now first thing is between the pair of parentheses do. Do is an indicator that we want to repeat the set of statements. Then the first step, first section of the Lisp code says that if you are having m variable, namely where 1, where 2, where I, where m, which will be involved in the iterations, then you will have a section of the code which will be used for initializing the variables and then changing the values of the variables in subsequent steps. So friends, the first section of the do loop which is given on this slide is you write the name of the first variable, then you write through init1 the initial value of this variable, and then you have step which tells us how the modification to the values of the variables are to be done, the corresponding variable is to be done in the subsequent steps. Similarly, variable 2 is there, then what will be its initial value, then the third symbol is standing for the code which is to be called for modifying the value of the second variable, and so on and so forth. So friends, this is one segment of the iterative loop which is known as do loop. What are the rest part of the do loop which are given on the next slide? Then we test. When this, whenever there is an iterative loop, we must have conditions by which we are able to tell when this do loop is to be terminated. For example, if you want to print a number of first natural numbers, the process will never end if every time we print a number and add 1 to it and go on like this one. The process becomes unending. So we have to give that now say we want to print the first natural numbers up to 100 only. So there have to be terminating conditions for a do loop, otherwise the loop will continue forever. So the second segment which is given within the pair of parentheses is for what is the end test end. Not only that, please don't look at the slide. Not only the end test, but also what other modifications are to be made to the parametric values. So now let us have a look at the slide. That is the second part or second section of the do loop consists of what is the test by which the execution of the do loop will be terminated, and during the termination what will be the possible changes to the parametric values. And finally it is body 1, body 2, body and show that section of the do loop through which the various statements which are required for achieving the objective are written over there. So friends, once again we look the whole syntax of do loop by going to the previous, that is first the do word is there, then the initialization steps section which indicates the initialization steps is there, then the end part section is there, and finally the body part is there. Just by reading this we may not be able to understand. So now let us go to an example. We illustrate the do loop. Do loop is for the purpose of executing the same code a number of times. And now we define a function using the do loop and see its significance. For example, in this particular case, we want to print the first n natural numbers. How the function will be defined? Let us have a look at the slide. The slide says that first of all Please look at the slide. Please look at the slide. We are defining a function which is intended to print the beginning integers, and the first n integers are to be printed only, because after the process is adding one number and printing, therefore it is an iterative process. That is, first of all you will find out a number which is initially 1, and then you will print, then you will increase it by 1, and then you will print, and so on. But at every step we will check whether the current number is equal to n or not, because we are to print the first natural numbers only up to the integer n and no more. Therefore, 2 steps, or rather 3 steps are required at each stage for printing a number. First of all, a variable count is taken, and initially the value of count is 1. However, in the subsequent steps, plus 1 count, that is, count is increased by 1. Then what is the next step? Terminating condition. That is, we are using only one variable count on which the iteration is applied. Every time count is incremented by 1, and then it is outside the iterative loop. It is compared with the value n which is given as a parameter. Suppose at any step the count becomes equal to n, then in that case we may print out done, a word done, which will indicate that the task is completed. But in order to explain the significance of the do loop in the definition of print beginning integers n is a parameter which indicates that we will be printing the first n natural numbers. The iterative part is that the count is incremented by 1. The terminating condition is that find out the value of count, whether it is equal to n or not, and in that step itself will print count, because I told you that when we check the terminating condition is 2, then we can give a number of steps, and in those steps one of the steps may be print count. So this gives the complete definition of print beginning integers, for which n is a parameter which indicates that the number, the integers which are to be printed are from 1 to 3 up to n. No integer beyond n is to be printed, and the definition of that is given on the slide. Now let us execute it. So for particular execution we will have to give some parametric value to the integer n. So friends, next command which we give, print beginning integers, that is, we are calling the function which we have just now defined with the value of n as 12. That is, 12 is the parametric value of n. So what will the system will do? Please let us go back to the previous slide with n is equal to 12. What it will do? First of all, it will initialize count to 1. And then what it will do? It will test whether count which is 1 here is equal to 12 or not. No, it is not. So it will be printing count. The value of count is 1. So it will be printing 1. Then it will go back again. That is the significance of the word do. That is, now count have a new value which is obtained by adding 1 to it. So now count becomes 2. Again 2 is compared with 12 for equality, and we know 2 is not equal to 12, therefore the terminating condition is not true, and therefore it goes to the next step. The next step is print count. Count's value is 2, so the 2 is printed, and then again we go to the statement count plus 1 count. So here the value of count will become 3. Again 3 is compared with 12 for equality, and we know 3 is not equal to 12, therefore no termination is to take place, and again the value of 3 is printed. Now in the process, when the value of count is being incremented in successive steps, ultimately the value of count becomes 12. And therefore, now when we come to the statement equal count n, that is 12 equal to 12, yes. So at that step the system will print done, and it will not go ahead. That is, no more steps will be executed now. So let us have a look what will be the output. The output in this particular case, you can see first the integer 1 is printed, then the integer 2 is printed, then the integer 3 is printed, and you can see the integer 12 is printed, and finally done is printed. Here done is used to indicate the successful completion of the loop. So friends, this way we have told you how to define a function in which a section of the code has to be repeated, may be repeated rather, and how to terminate that repetition, because otherwise the repetition will continue forever. Now there is another very important construct which is called let. The purpose of let is to, instead of global variables, it sometimes defines local variables, the range or scope of which is only for a section of the code and not for the whole of the code. For that purpose, the language Lisp provides a let construct, L-E-T, let construct. How it is defined in the language Lisp, let us have a look at the slide. Please look at the slide. For we are explaining this. We are explaining how let construct is used in defining local variables through an example. So we are defining a function. The name of the function is explain let. That is, this function is for the purpose of explaining how the let is used in defining local variables. So first of all, there are two variables or two parametric values x and y which are used as parameters to the function explain let. Now the let clause starts. Let, and you can see there are pair x1 is one clause, y2 is another clause, and then the let is closed. What is the meaning of this one? That only for the section which is between pair of parentheses corresponding to let, and the scope of let continues except the last two lines. How do we know that the scope of let is only up to the leaving out the last two statements is known through the pair of parentheses? I have repeatedly said that pair of parentheses play a very important role in language Lisp. So the parenthesis which precedes the let matches to the right parenthesis which is given on the third line from bottom, which indicates that whatever is there in which the x is associated with variable 1 and the variable y is associated with 2 is valid for all occurrences of x which are within the pair of parentheses which precede let, and the right one of which is up to the third line from bottom. However, outside this right parenthesis, that is on the two last lines, this x and y are not having values respectively 1 and 2. Rather, these are parameters. I again emphasize that the x and y's which occur within the pair of parentheses bounding let will have x as 1 and y as 2. However, whatever x's and y's occur outside these pair of parentheses, that is in this particular case on the last two lines, these x and y's are not having necessarily the values 1 and 2. Rather, they will have those values which are to be given as parametric values. Suppose we give the parametric value 8 to x and 9 to y. Then what will happen? That the first print statement will print 1 because it is within the scope of let. Similarly, the first y will be printing 2 because again this y is within the scope of let. However, the last two print statements will not print 1 and 2 respectively, but they will be printing 8 and 9. This is a very important point to understand, that whatever are the variables within the scope of let will be having the values, local values assigned through the let statement. However, those variables whose occurrences are outside the scope of let will have the variable values which are not necessarily the same. So friends, let us call the function explain let with argument values 8 and 9, and as I have already explained, that first print statement will be printing the value of x as 1, the second print statement which prints the value of y will print 2, because these two print statements occur within the scope of let. However, the last two print statements are not within the scope of x, therefore these occurrences of x and y are not bound by the values 1 and 2 respectively, but rather whatever are the parametric values given to x and y, and in this particular case we have assumed that the value of x will be 8 and the value of y will be 9, and therefore the last two statements will be printing the values 8 and 9 respectively, which is obviously given here also. So friends, this is how I have explained three very important constructs so far. First was the cond construct, the purpose of which was that out of a number of conditions, only one condition or sometimes more conditions may be true, and then number of clauses are given. So if a condition is true, the sequence of statements which are given within that clause are to be executed. However, if the condition is not true, that is, it is false, then sequence of statements following the test condition will not be executed. And then I explained the do, that is the iterative construct in the language Lisp, that is do construct provides us a mechanism by which same code may be executed for different data. And third, I explained how the local variables can be defined in the language Lisp through the let construct. Now we will be using these constructs in more definition in order to explain how do, let and cond are useful in solving problems. So for this purpose, please look at the slide. In the slide, what we are going to define, we are going to find out the I raised to power j. We are going to define a function which computes I raised to power j. For example, if I is 2 and j is 3, then in this particular case, this function which we are going to define will compute 2 raised to power 3, that is, it should return 8. Similarly, if I is equal to 4 and j is equal to 4, then in this case it should return 256, that is 4 raised to power 4. So friends, how to define it? The definition of this, first of all, let us plan it. What should be done in order to find out I raised to power j? That is, in each iteration we define a new variable, say x, and initially we give it the value I. Then in each successive iteration we should multiply I by I, and then whatever is the result by I, and then the new result by I. But when, up to when this process is to continue? The process must terminate when the number of times the I has been multiplied becomes j, because we have to find out the value of I raised to power j. So there must be a condition which tests whether we have already multiplied j number of times or not. Once we have multiplied I with itself j times, then we will stop the process of multiplying it and return the value. So this is the essence of what we should be done by the Lisp code. So, and how the Lisp code is written in order to the process to code the process which I have just now explained. Please have a look at the slide. So what we do in this particular, please don't look at the slide. we are defining a variable answer which will be used as a partial answer. So initially the value I whose powers are to be computed is given as its value, and in subsequent steps whatever is answer obtained at a particular step is multiplied with I, and that is, I have already explained that initially I is stored in a variable answer and it is multiplied in subsequent steps with itself, and the multiplication is to be carried out j times. So how we should compare whether we have multiplied it by j times or not? What we do, we reduce j in every subsequent step, so that the additional number of times I is required to be multiplied is known through the variable power. So the power is denoting the number of times by which I need to be multiplied with the already obtained answer. So friends, when this counter variable which is counting this thing becomes 0, then in that case our process is completed of finding out the value of I raised to power j, and we should stop. So the last condition, first part except the last line, the rest is within the clause of the definition of iteration part, and the second clause which is there, or second section of the do loop, is to test, and 0p means whatever is its argument, is it 0 or not. If it is not 0, then you will not execute, that is, you will not return the value of answer. However, if the counter is equal to 0, then you will be returning the answer. And now let us take, we define the function expo. Now we associate value I to 2 and j to 3, so we will be seeing how 2 raised to the power 3 is found. So initially the value I, which is 2, is given to the answer, that is the initial value of answer is 2. Then power is defined, which is j, that is in this particular initially the number of times it is to I is to be multiplied, and j we have taken as 3. So initially power is assigned 3. Then the counter is actually the number of times left for multiplying i's. So if initially answer is I, the number of times it additionally required to be multiplied with itself is 2 only. So initial value of counter is minus j1, that is j is initially 3, so 3 must be reduced by 1 to 2, that is the number of times I need to be answer need to be multiplied with I is 2 only. So you can see in each subsequent step the counter is reduced by 1. Initially answer is 3, answer is 2, then the next time answer is 4, still next time the answer is 8, but at that stage counter becomes 0, and 0p counter will become true, and hence the answer 8 will be returned. So friends, this is how the 3 constructs, particularly the do construct, is used in defining iterative computations in the language Lisp. We know that whatever computation a computer does are all useless if there are not provisions for giving data to the computations as inputs, and whatever a computation is done finally are not returned to the user. All these computations become useless. So it is very important for any programming language to have constructs or have provisions by which the values can be given as inputs and values can be given as output by the computer system, so that we can have an answer to the problem which we have given to be solved to the computer system with parametric values. So what are the provisions for input and output in the language Lisp? Let us have a look at the slide in order to know what are the input statements and output statements. So friends, in order to read a value, read statement bound by a pair of parentheses is given to us. So for example, there is a instruction plus 7 read. Now once this statement is executed, once the read is encountered, the computer system waits for an input from the user, and suppose at that particular time the user gives the value 8. So after reading the value 8, the system will be executing the statement plus 7 and the value 8 which is given by the user, so the answer 15 will be given. So friends, we will continue with our discussion of input to output primitives in the next second half of this today's lectures. Thank you.